This is 4.2. We are going to be working on trig functions as they are defined on the unit circle. All right. So first of all, we need to do some definitions here. So the unit circle is a circle with a radius of 1 that is centered at the origin. And every point xy on the unit circle satisfies the equation x squared plus y squared equals 1. That's actually a very, very important equation, and we are going to see that come back in a little bit here. Okay. So when we're considering the placement of um, points along the unit circle, okay, as we move in a counterclockwise direction, our point values are positive. And as we move, or not point values, yeah, the point values. As we move in a negative, in a clockwise direction, the t values or the point values are going to be negative. Okay. Now, the question is, why is it called the unit circle? Well, it's called the unit circle. Wait, where's that definition here? I know I've got it on here somewhere. Sorry, y'all. Well, it's called the unit circle because the radius, if you notice here, we have a radius of 1, and the arc length corresponding to any t value is equal to the angle in radians. So recall we looked at different ways of measuring angles previously, and one of those ways is radians. And if you notice, radians does have that root here, RAD, for radius. This is why they're called radians. Okay. Now, before we get into the measures on the unit circle, I want to take a little bit of a detour here. Okay. And let's come out to the side here where I would like to remind everyone of something that you learned in, oh goodness, probably Math 2, definitely Math 3. Okay. And if you remember, you all learned about what are called special right triangles. Okay. So you learned about a triangle called a 30, 60, 90 triangle. And if you recall from that, okay, the side length measures of a 30, 60, 90 degree triangle, this would be 1x, the hypotenuse is 2x, and the long leg is the square root of 3 times x. Okay. Then the other triangle that you learned about was a 45, 45, 90 triangle. Okay. And if you recall from that, the legs were each 1, and the hypotenuse was the square root of 2. So when you learned about these special right triangles, this is what is going to be the core and the foundation of building our unit circle. Okay? So it is also important to remember that um, the sine of t is synonymous with y, cosine is x. So tangent is sine over cosine or y over x. Okay. And these are just ways that we can kind of look at how this works. Okay. So I actually want to jump forward here to our unit circle. Okay. Because if we are at 0 degrees or 0 radians, then our coordinates are 1, 0. If we are at 30 degrees or pi over 6 radians, our coordinates are the square root of 3 over 2 and 1/2. If we are at 45 degrees or pi over 4 radians, then our coordinates are root 2 over 2 and root 2 over 2. If we're at 60 degrees or pi over 3 radians, then our coordinates are 1/2 and root 3 over 2. And then if we're at 90 degrees or pi over 2, our coordinates are 0 and 1. And this is where the special right triangles come in. Okay. So let's go back to our special right triangle. Or actually, let's kind of pause right here with our right triangles. So if we think about that this is our angle, okay? We could actually create ourselves a little right triangle here. Okay? And remember that this is going to be 1x, 2x, and root 3x. Okay? So that means that the sine of pi over 6, okay? So remember our SOHCAHTOA. So sine of pi over 6 is going to be opposite, which is going to be, sorry, I didn't mean for that to go smaller. It's going to be opposite, which is going to be 1 over hypotenuse. And our cosine of pi over 6 is going to be adjacent over hypotenuse. So knowing this, you can build the entire unit circle by only knowing those two special right triangles. Okay? And remembering one mnemonic. And that mnemonic is all students take calculus. And what that breaks down to is in quadrant number 1, all of your trig functions are positive. In quadrant number 2, only sine. In quadrant number 3, tangent. And in quadrant number 4, cosine. These are the ones that are positive in each of those quadrants. And because of that, we can come along and we can fill in the unit circle, like I said, with only knowing those few things. Okay? So, like I was mentioning before, we're going to come back up here now. Okay? Sine is y, cosine is x, tangent y over x, cosecant 1 over y, secant 1 over x, and cotangent x over y. And remember, these are coming from those reciprocal identities that we learned. So armed with that knowledge, we can figure this out, that if the real number t corresponds to this point, okay, we want to find sine, cosine, and tangent. So remember that sine of t is equal to y, which would be 12 over 13. Cosine of t is x, which is going to be 5 over 13. So tangent of t, we know, is y over x. So what would that be? Well, it's going to be sine 12 over 13 over cosine 5 over 13, which simplifies to 12 over 5. Okay. The last thing that we're going to talk about here is domain and range of our trig functions. And then we're going to come back and do some examples. Okay. So domain and range. So the domain of sine and cosine is all real numbers. There are no restrictions. The range, though, is only from -1 to +1. Now, tangent is undefined when x is 0. Secant is undefined when x is 0. Cosecant is undefined when y is 0. And cotangent is undefined when y is 0. Okay? So let's come back and look at these examples. Okay? So we want to identify the ordered pair on the unit circle that corresponds to the number t equals 5 pi over 3. And then state what sine and secant are. So take a look back at your unit circle that you filled in and find 5 pi over 3. First of all, what quadrant is 5 pi over 3 in? 5 pi over 3 is in the third quadrant. Okay? And in the third quadrant, remember, tangent is the only thing that's positive, which means that sine is going to be negative and secant is going to be negative. So when we consider where 5 pi over 3 is,